Part D. In the UK, electricity is delivered to consumers by the national grid. Explain the main features of the national grid. And remember, explain is describe plus say why. Okay, so describe the features and then say what they are. And it's worth 6 marks. So 1, 2, 3, 4, 5, 6 different bits. Okay, there's quite a lot of space here. And the reason, in fact, I might not, because there's so much space, I might take the top line and draw a little diagram of what the national grid is. So I can remember that the national grid contains these things, these bits. There's pylons, and we've got these things. This is a step up transformer. We've got cables, pylons, and then over here we've got a step down transformer. This is the power station over here. Okay, not part of the national grid. And over here we've got the homes. Okay, so we get electricity from there to there. So we get that there. So we're going to talk about the step-up transformers. We're going to talk about the cables and the pylons, the network of cables and pylons, then the step-down transformer, and that's it. So I'm going to describe each bit. I could almost use headings here if I wanted to, but I'm going to talk about the step-up transformer to begin with, describe what it does, why it does it. Then I'm going to talk about the cables and the pylons, what they do, why do they do that. Okay, so let's start off. So step-up transformer. Transformers increase the PD, potential difference, of electricity from power station. Okay, so that's what they do. Why do they do it? This is to reduce current, and lost energy by heating. Okay, so that's the key bit, is they do it so they don't lose energy by heating of cables. Next, the pylons and cables. Connect areas around the country, connect power stations to where people live. Okay, what happens? Well, they've got thick cables, high in air. Okay, so why do they do that? Thick cables reduce resistance. So less wasted energy. Why are they high up? Okay, so they're high up in the air to be safer, so people don't touch them by accident. Okay, next, so that's the step-up transformer. I've described it, explained it. The pylons and cables, I've described them, I've explained why that's useful, why they're designed like that. And the last one now is the step-down transformers. So step-down transformers decrease potential difference So they decrease the potential difference of electricity from cables. Okay, why do they do that? Well, they do that to make it more easy to use. So it's easier and safer to use in homes. If if the electricity in your home was still running at 12,000 volts, then every time you walked near an electrical plug, you'd be electrocuted. It just wouldn't be, you couldn't do it. So this makes electricity easier and safer to use in homes.